Wait, have you? Yeah, okay.
Welcome everyone to this week's IPLD sync meeting. It's November the 30th, 2020. And as every week, we go over the stuff that we've worked on in the past week and discuss any open agenda items. Today, we even have an agenda item. That's good. But I start with myself, so not that much IPLD, but kind of. So I was working on a storage system for content addressable data. Currently, the main purpose is Filecoin, but it's really generally for content addressable data, therefore relevant to IPLD. Yeah, it's still a prototype. It's not finished. You can't even get data currently. You can only put data, but this is the next step. And yeah, so it currently looks pretty promising. If you run it on a huge machine with 700 gigabytes of RAM, it works. This was amazing. Like it's fun to work with those machines. Yeah, but yeah, probably more on this in the coming weeks or so. But if anyone is interested, it's written Rust, and I've put the link in there, and yeah, feel free to check it out. Next on the list is Danielle.
Cool. So I released Go multi-codec, the tag that I spoke about last week. So actually, when releasing that, I ran into a bug where the Go proxy on some database, which are like a central place where you can download Go modules and source code and so on, they kept giving me weird errors for like half an hour. And turns out a couple of other people at PL ran into the same issue months ago. So I raised an issue upstream about that. It's kind of like that TV show where you try to fix one thing and then you find another thing that's broken, and then you find another thing that's broken, and then it's like a chain of why is everything broken when I try to touch it. Anyway, that was frustrating. And I'm just replacing the old code that inlines the constants as I go with this library. I also spoke to Eric, and we planned a bunch of IPLD Prime releases. So the TLDR is that we're going to do 0.6 this week, and then 0.7 is going to include a bunch of backwards and compatible changes that we've talked about for a while. And we also reviewed and merged some stuff that has been flying for the past few weeks. And what I've been doing for the last couple of days has been figuring out how to automate some of the larger low-level changes, such as making the as foo, like the as boolean, as string, and so on methods, not return error, because that's an easy enough change to make in the interface, but it's going to touch, hundreds or thousands of lines of code, and doing that manually is just horrible. So I've tried a couple of tools, they didn't work, and I think I know I figured out a way to do it. And I also spoke to Adine on Slack because he raised a good point about you can do a little bit of trickery in Go with a single line where you index into a map and also assert that to be a certain type. And both things can also return a Boolean. And if you do both things at once, it can be confusing which Boolean you're getting. If you think about it hard, it's kind of obvious that it's the second one, but if you just skim the code quickly, it can be confusing. And Go IPFS, we found like 4 different bugs because somebody confused the semantics of this Boolean. So we spoke about it for a while. That's the thread on Slack. And I drafted a proposal for the Go language to try to restrict the sort of hackery of doing both things at once in a single expression. I reckon it's going to be rejected because it feels kind of, I'm not sure about it. But at the same time, if people keep getting the semantics wrong and it's a confusing corner case of the language, it might be worth restricting. I don't know. I'll probably raise it next week. So if anybody has any feedback, it's welcome. And also my second priority for Q4 was writing a CI best practices document for Go. And I thought it could be upstreamed because it's sort of generic. It's not just about PL. The problem is it sort of stalled upstream because I waited for a month for their technical writer to respond to me, and he just didn't. And then when somebody else finally responded to me, they said, well, we don't know where this document could go, so just stick it into the wiki. And the wiki is the GitHub wiki, which is horrible. The reason being that, you can post a page there, but anybody can edit it. And the only thing I can do is subscribe to changes. And if anybody spams it or deletes my content, I have to then go back and, revert that. And it's really annoying. So I don't know what I'm going to do. I might just publish this as a PL document after all. And that is it for me.
Thanks. Next one is Michael.
Yeah. So Thanksgiving was last week, so it was a pretty short week. But I got a little fed up. I was debugging CADB and realizing that the way that I implemented the tree is just like the abstractions like aren't in the right place to debug it well, and it's like a total mess. So I did my third implementation of these trees, which are now called chunky trees, by the way. Macola just isn't comfortable naming things after him, so they're called chunky trees now and not nickel trees. So I did a third implementation of these trees now with the intention of the base, having it be like a base abstract kind of type system a little bit, like for the trees, so that I can implement CADB on it or any IPLD trees. And so IPLD trees are sort of like they're basically, they're using like the base classes. Anyway, if you look at the implementation, it makes a lot more sense than what I'm saying. But then with that library, I've now implemented a CID set, a sparse array, an ordered map, and a database index. They all work really well. And yeah, the tree is really holding up. Like we can just kind of crank out these data structures now on these chunky trees and just vary some of the key types and other stuff. So it's actually really, really nice. So that's looking really, really promising and really good. These trees are fantastic. Also, like just having the implementation this kind of clean and abstract, it allows you to just like bring the branching factor way down and really kind of control where things are so that you can then write tests that cause the right merges and things like that in a really predictable way. When I was trying to sort of debug these things and write nice tests for them in a kind of fully materialized data structure on top of it, it's just too unpredictable because of all of the hashing randomness. So you don't know when you're going to hit some of these cases and when you're not. And then you change like a tiny implementation detail and all of a sudden none of that stuff works anymore. It doesn't do what it used to do. So it's all just like a lot nicer now. And yeah, that's it for me. I don't know who's next.
Next one is Eric.
I'm having one of those, trying to remember what I did all weeks. So one of the big things is I've been trying to work on a document that accumulates some known goals for the new year, just so we can have those written down someplace and maybe start to circulate it around anyone else who wants to be aligned on that scale of planning. Trying to look ahead an entire year is probably, we can try and we will try, but it will be an imperfect document that I'm sure we will make many smaller, more local in time plans throughout the year as well. Anyway, so there's a link to a document there for this. It's full of a lot of brain dump from me, but it could improve by having more brain dump from other people too. So I'd love some review on that. I think Daniel already took kind of most of the wind out of my sails in discussing that. We're planning some new releases for the Go IPLD Prime stuff. Did some merges already. I'm going to be doing a few more this week, basically trying to wrap up and nail down anything that could move. And then we want to tag one version coming up very shortly, which will be a minimal breaking changes. Almost nothing should surprise anyone when they jump to this. And then as soon as we get that safe checkpoint, then we're going to move ahead and do a bunch of API changes that are going to require manual intervention for somebody to upgrade across them. And we're going to try to get a bunch of these done really quickly within a month, at least. And these basically all have the goal of usability improvements to the core interfaces that we figured out from just more use over time and the feedback we've gotten from integration so far. For example, one of the big ones being using our node interface, the thing that kind of feels like an AST. It is, it's costly because a bunch of the read methods all return a value or an error. And that means that you can't chain those calls. So syntactically, it's just kind of a big pain in the butt. It's the best of Go code. It has if error branches on almost every alternate line. Nobody likes that. What a surprise. So we're going to try to trim down some things like that. But those will be breaking API changes by necessity. So we're going to try to do them all in as small a window as possible and then move on. And hopefully anyone starting to interact with this library by the time of the new year will get the new improved experience of less errors. Yeah, that's about it.
Next on the list is Ron. And the answer is no.
Who was that to?
To the nodes in the HEC pen.
I'm ranting about the formatting of this file a little bit. Some of the spacing wigs me out.
Okay. Okay. My week has just been all Filecoin and just swimming in data, and so I've been trying to tackle the issue of the volume of data in Filecoin, and in some ways I'm coming at it differently, but to the same issues that Peter has been dealing with just the volume of this stuff. And it's just so many things break down when you're dealing with this much volume, and also the fact that everything's so small, all these blocks are so tiny, and there's so many of them just to navigate through everything. And it shouldn't be surprising because it's how so much other real world data is, but it just makes everything hard. And especially it's not a static data set either, so it's constantly being added to. So when you feel like you're on top of something, then there's just more stuff to get on top of. And so I've just been writing utilities and trying to make practical ways of dealing with this data, and also dealing with space constraints. And it's just it's becoming frustrating. And yeah, there's some other Filecoin related stuff in there, interacting with the specs actors team and talking about data structure shapes and sizes and algorithms. And I think I shared with most of you some of the things that have surfaced out of that about the way the incentives driving the size and shape of their data structures, and some of the feedback I've given about that, but also it's probably worth us discussing at some point, just because they're trying to apply fairly brutish methods of costing the various operations with regard to IPLD that are gonna, like when you simplify anything in a complex system, then you end up with these things sort of bursting out in unexpected and unwanted ways. And I think we're already seeing some of the fruit of that, but we will continue to, unless I guess we have some good ways of speaking about the way that the different constraints cause different trade-offs. Anyway, that's been my week, and it's just I don't have much to show for it other than frustration. And I'm also really behind on my GitHub backlog. So if there's things I haven't responded to, then yeah, I'll catch up.
Thanks. Next is Peter.
You're muted.
Sorry, the joke was what Rad said. Same here. Yeah, basically multiple requests to move this large set of data to different parties for different tests and so on and so forth. I think I finally have a solid way forward that actually works, and I just need to tweak the schema just a little bit more, where the original idea was to have the block accessible via some kind of synchronous block store, like like the test3 or IPFS in the future, whatever it is. The amount of blocks that we have makes this absolutely impractical. Even with any kind of fan out that you can do, there is just not enough there are not enough round trips in the day for you to even pull a single state out, let alone something for analysis. So the version that kind of I'm settling on that seems to be working, and we'll actually be talking with Will a little bit after this call on how this can be integrated into Sentinel, would be a humongous Postgres database where we publish it is sufficiently normalized, but it doesn't actually go into like all the way into breaking down the blocks as far as like Sentinel, but it does actually maintain the relationship between individual blocks. So actually pull out I parse every block before I put it in, I pull out the links, and I actually recreate the linkage within the database itself, which basically lets me do things like exports and other stuff the same way like you would do by traversing a tree, but using it with with recursive CTs, which obviously is way faster than anything we can do on the Go side, because we have to unpack a block and so on and so forth. Whereas if I actually have the graph in the database, it works. And moreover, because all of this is sufficiently compressible, it is practical to start publishing base backups of this database like every day or so once it is working and it is caught up. Like once I started running, back of the envelope says that it will take 8 days to actually run through the entire chain, because I cannot just import an existing data store. I need to reanalyze every single block, and there is a little bit more nice. So basically, for every block that comes in, I found a way to record when in time did it happen. So we also have temporal clustering of blocks and so on and so forth. Plus, there is something similar to file system real-time. So actually, we can tell a particular block which epochs touched it throughout time, as as the chain was progressing, which will it's not clear what this will allow us to do in the future, but recording this information once and keeping it forward is virtually free. So we are going to collect this as well. And you can publish a base backup of this and then publish a streaming wall of that, write catalog. So essentially, anybody who wants to get this humongous database running, they should be able to just pull a recent backup from IPFS and then sync up to. There will have to be like a series of slaves to not jeopardize the main database. But if everything works correctly and it scales as my initial testing shows, this will be a way to provide the data to whoever wants it in a very cheap and relatively decentralized way. So this should be solved. Of course, it doesn't help with how many actual rows you have in these tables and so on and so forth, but that's how it is. Just don't unselect star count, because because that is taking a long time. Yeah, so there is that. And another piece of news that's related to IPLD is that literally, that's why I was actually late. This is the first time we are doing actual dumbo drop deals with a real sector, with a real miner, with a real everything. Things are going way better than I expected based on my previous experiences. So hopefully we will have our first sector sealed, and if it works all correctly, and if the power shows where it's supposed to show, the rest is simple matter of automation at this point. So yeah, fingers crossed that will go without a hitch. And yeah, that's my week IPLD wise. Who's next?
Chris, do you have any update?
Yeah, I got validation plugged into the GraphSync requester, so that's good news. I'm moving on to adding extensions and then responders. So That's my update.
Thanks. Okay, so I have on. So I have one agenda item, which is about also one of our favorite topics is about inline CADs. It came up again with the DAG Jose spec thing. And so I had a talk with, chat with Drell, who is working on those things. And also like before I had a talk briefly on Slack with Eric about like inline CADs and couldn't we do schemas differently and so on. So long story short is like, it was interesting to me because like from like I've encountered inline CADs from like implementing them in Rust and stuff like this, and see like how they kind of like can fall apart because well they are not fixed size and different things. So from my perspective, like it was just like you shouldn't really use them because they are not really content addressing things, but just like different types of things, and you just shouldn't use them. And I was happy to see that you can use schemas as a replacement perhaps for those cases. But as I've talked with Drell about it, it was interesting to see like from an application developer's perspective, they're just super useful. Like, so if I wouldn't have the whole like background of like how to implement them or whatever, it's like, it's really nice to use. And what I ended up with is what was interesting, and this is what I kind of like would want to discuss or just like, yeah, point out is that a thing that, at least from my understanding, is what inline CADs also give you, which you can't currently do with pure schemas, is that you can still traverse the whole thing transparently. So let's say in the Jose thing, or like, yeah, in the whatever, like in the Jose part is you have JSON and the payload is currently defined as a CID. It could be an inline CID, and you could even port, like, so if you put a normal CID in there, of course it goes to a different block, and you can just, no matter which format it is, you can just traverse it, no problem at all. And the nice thing about an inline CID is that you can even put in like CBOR, for example, within your JSON, but you can still keep traversing it as it would be a different block, and as CIDs transparently get resolved, you can just traverse them and you're fine. And so if you use schemas, obviously your thing will be either CID or it will be bytes or some object, or yeah. So the traversing really changes. So really like your traversing path is different depending on whether it's inline or not. And from an application developer's perspective, like that's super useful if it's just the same thing. Like you just don't care. You just can just traverse them. And that's something that I think if you do it with a schema and a union between like a kind of union, you lose this feature kind of. Well, and I can see why people would like it.
The traversal path isn't different when you use the same object. If you use the same body, like if you use like the same decoded body as the union, then it wouldn't, it's the same traversal path, it doesn't change.
No, because
it's only when you have these byte values that you're talking about that you would have the problem.
Yes, so as soon as you have a different codec, you have the problem.
No, oh yeah, exactly, yeah.
So if you switch between codecs.
Yep.
Which you probably shouldn't do, but.
Yeah, but that is what's happening in the DAG Jose stuff, right? Like they're switching between codecs.
And so which I think is also what at least I would like to like kind of like advertise with IPLD, that those things are possible. Like the nice thing about IPLD is that you can link between different things and it potentially just works.
Mm-hmm. That linking between types becomes much more useful when one of those types is like the signing and encryption container as well, which is the case for DAG, Jose, and Cose. Like that the usefulness of that is presented to people in a much clearer way there. Whereas like most people, when they're building an application, they're like, okay, I'm only going to use DAG JSON, or I'm only going to use DAG CBOR. They're not going to be switching between them a lot. But if you're signing things and you're using these signing containers, then it starts to really matter.
Yeah. So what I then also like came up with is like, so because we had a similar discussion about like in Filecoin, there's something where you also store CBOR or DAG CBOR in a field as bytes, which is like, again, like like it's not the question if you should do it or not, but just like it's a case. And if this, for example, would then be an inline CID, which I don't propose to do, but if it would be, you could just traverse it, which is kind of nice. So the question to me is I think it's a nice feature, and like I still think like inline CIDs is the wrong tool for doing it, but the question is, should there be a way in IPLD somehow to do such things?
I feel like inline CID is the right thing, but that's just my view.
So
I mean, like they are useful in some cases. They just like cause a lot of weirdness in other places.
Yeah. So yeah. So have anyone any thoughts on this, or just like should we just like skip it to next week or to the next meeting to see like if anyone has like had some thoughts, and if not, like it just came up in this PR and I just found it interesting to think about, should this be a first class citizen, or do we still say don't use them, use something else?
It's funny to me how people who actually did use inline CIDs before were telling you this thing like about 6 months ago, and you're like, no, inline CIDs cannot be possibly useful.
Yes, as I said, I was like, I haven't had this perspective from an application developer perspective. Basically, I was too deep into the details.
No, I mean, it's not an I told you so. It's just a very funny,
it is. It certainly is. Like,
I think the thing that we're still pushing back against on one of those threads is not like the idea of ever using inline CIDs when you think that they might be valuable. It's literally like having some auto magic logic where whenever you're about to encode something and link to it, you decide based on the length whether or not it should be an inline CID. And effectively you're turning like every link into a potential inline value. Like that's where things get really tricky.
Right. I think the fundamental issue that we had with things like inline CIDs is actually that it's an example of a slightly more general problem that we just happen to see most of the time with inline CIDs, which is that schemas and any of our other descriptive techniques are actually intentionally generic over codecs and other choices like this, meaning they don't talk about them because to talk about them would reduce flexibility and utility. And that means that if somebody is switching between different codecs or switching other parameters of linking, like switching to an actual link versus an inline CID, then we have very little ability to describe the switching. And that makes a lot of discussions get much harder whenever these things appear.
And we don't have entirely consistent handling in some places. Like we're still not entirely sure about this car file thing. Like Steven seems to think that they're in the car file and Peter doesn't think so. And I don't, in my view, they actually shouldn't be their own values in the car file. Like that's just a waste of space. But no, I mean, like they're definitely useful in some cases. I mean, I stand by like my original analogy, which is that they're data URIs. Like they're the same thing. Like you take the value of the address and you put it in the address. You make it the address, and those work like 90% of the time. Like data URIs work like 90% of the time. Like they're really useful when they do work. I use them, but sometimes they don't work because sometimes you need an address to be a value type, and they don't work very well as value types, and they don't have the same guarantees as address value types. So yeah, I mean, I at one point I had some objections around the fact that because it's not a hash, an actual hash, there are assumptions that you might make about it that would be problematic if you're trying to use the link as a value type, which is true, but upon reflection, I don't think that it's any different than just insecure hashing functions are. So if you're ever using a hash digest for something that you need it to be an actual hash digest, you need to check like the multi-codec anyway. and or check the multi-hash and make sure that it's a secure hashing function, because it could not be, and you could have the same problem.
So what they, for example, need for the COSE and CHOSE is that they so inline CIDs are kind of have 2 bytes or like 2 variants more than you would need, because what you basically need is you need an identifier, what the codec is, the length, and then the data. And what I thought of, I thought I had was perhaps there could be in the future a CID version 2, which is defined in a different way so that it could also be codec length data. So basically, if you, for example, would flip from multi-hash, you would flip the length and the hash function. Not quite, but just as an idea that could basically, or just would it make sense to come up with something that is kind of reads like a CID, but it's not a CID. Again, it's not something that I push for or proposing. It's just a thought that it might be a useful concept to have something in IPLD which is just codec length data. And then it happens that CIDs follow the schema, basically having.
You're only saving 2 bytes, and if we ever do another version of CID, we're going to have to deal with a lot of code that just checks the first byte, and if it's not 1, it freaks out. So it would just be a huge amount of work to support this everywhere, just to shave 2 bytes. So it's just probably not worth it.
I also think that probably it's not. Yeah.
You could imagine doing something like this in a codec though that was very aware of inline CIDs, and it just shaved bytes this way. So it had its own typing token for it, and then could identify it. So you could do this reduction and have this type within a codec as a method of compression, and that's probably good enough.
Should then in reverse be inline CIDs more of a first class citizen than if we because truly I have the feeling that we treat them well, they're there and I can use them, but they might break, they might not break, and it's so yeah. Do we then have plans to say, okay, that's a proper thing, it's not really a hash function, depending on the definition you use for a hash function. But we're still okay with it, and yeah, it's very well supported in our tools and so on. Or do we just keep saying, well, this thing exists and you can use it and we'll see what happens? I mean, it's also totally fine.
I think
do we have a doc on this in the spec repo yet?
Practical in the first place, and no, we don't have a doc on this. We should really get a doc on this. I'm not super convinced by some of the reasoning that we entertained earlier in this call about why CIDs are superior. I think a lot of those things are actually still just equal. Transparent pathing will work the same way whether there's an inline CID or a link to another block or just an inline piece of additional content through a kind of union. Those are all transparent representation pathing level.
Really? If it's just bytes, how would you know that
not
it's
if it's just
bytes?
But don't do that though.
I mean,
either inline the value. Well, okay, if you're linking to a raw block, then it would be the same. Yeah. But you just inline the value data from the data model. But what Volker's saying is that when you need to do a codec switch, but it's often not just decode the data. Just decode the data and put the value in. Then you reduce the number of codecs that need to be used. The only case that I see this really being useful is this DAG, COSE, and HOSE thing, because you don't want to change the format of HOSE and COSE, and so you just want the binary value, which in JSON is fucking base 64 Erl encoded, and you just want to change the interpretation of it to say it's a CID, and so you actually don't have an opportunity to do a union or say it's any other type. It just has to be one type, because then you'd have to change the format. And we don't want to change the format, we just want to change the codec identifier. And so there you need, and also it has to be a link, because it is always going to be linking to something or doing something else in a different codec, like almost by definition. And so it really makes sense to use inline CIDs when you need to inline stuff there. The thing that I'm worried about though is that if you do this with encryption, it depends on the encryption function that you're using, but you're putting like highly identifiable known bytes at the beginning of the encrypted data or at the beginning of the decrypted data. So like you can use that to break the encryption. I think like some algorithms I think are fine and jumble things around enough where it's not a big problem, but some of them, like this is a problem. Like they would need to worry about this.
Okay, so I can see the point of like you probably shouldn't do a codec change in an inline. If you use inline CIDs, you probably shouldn't change the codec, which kind of like seems pretty reasonable for the normal use cases. Okay, yeah, I can see now that okay, then a kind of union doesn't make a difference. Okay, I can see that. Okay. So is the conclusion that we should write a document about like the topic about like inline CIDs and like also kind of like also describe like what cases we've seen, because we've seen plenty of cases and some we say yeah that's an okay case and some are not and whatever and
okay. I don't know if we want to so much say that's not okay. We want to outline.
Yeah, I agree. Sorry.
Yeah, just the surface area for decision making is what we should be in the business of.
Yes. Yeah. Sorry, this was just agreed.
You can do this, but here are some better ways of doing it, and here's some reasons that you may not want to do that because it may bite you later on. And I think this is really what we're in the business of doing. It's just mapping the decision space for people so that when they come along, they can make all those trade-offs that they have to make given their system constraints.
We also need to figure out what the current car implementations do with them.
What we are actually doing with inline CIDs. Yeah. I
mean, Peter, you would know since you parse these car files like all the time. Are there inline CIDs in the car file as unique entries, as unique blocks?
No, because all of Go has this condom in a way block store that basically does not allow any identity CID to go through it or be retrieved from it.
But you could plug the car thing into the lower layer. It depends on which layer you plug it into.
Yeah. So like, I mean, because if you write the car file by traversing the graph, you're still going to get the inline CIDs in the graph. So it doesn't really matter what the block store decided to do because they're values in the block data.
Yes, if you do this kind of traversal, yes, but basically we do the traversal from the block store directly when we write the cars. That's where it comes from. So,
but what do we do when we do the regular deal flow and you take a file and you traverse it and spit it into a car file in the regular deal flow?
All right, I don't know. This is actually a thing that we have opened a ticket for to verify what the different implementations do for this particular case. But yes, we haven't.
It would try and fetch it because this all relies on that. What is it called? ID wrap or something? Something. Yeah. There's just one specific layer in Lotus that deals with this identity block.
It's not nodes, it's everywhere. IPFS uses it. That's what I mean. In Golang, you basically have it everywhere in every single point. It's inserted, and that's why you never see this stuff leaking out.
Okay.
But you don't have to use that.
Correct. Yes.
But in my view, like we should just update the car files to not write these. And because like it's just a waste of space. And then that's the easiest thing to keep consistent since we know that there's these other wrappers everywhere that just like make them vanish. So
if people start writing DAG, Cose, or whatever this one is in JavaScript and they get validated in Go, then we'd have different behavior given this ID wrap thing. because we don't consider these identity hashes at all in JavaScript as a special case. And if they're doing that in Go,
okay,
then
yeah.
So I agree. Spec needs to be updated either way to be explicit about it, so that if people are making Filecoin deals and they're being validated on the other end, then yeah.
And in JavaScript, we have to do it in the car file library because I think the only thing that we pull from on the other end is that links. We just get a links iterator on the block data, and that returns inline CIDs like any other CID.
In fact, it also applies to what does GraphSync do. Because that's how you get the stuff across from, Lotus to Lotus.
Oh shit, that's right. Oh yeah. Oh no, wait, but in the regular deal flow, it goes over GraphSync, but then they both spit out car files. And then they compare the hashes on the car files.
No, not at all. Like, if you pull from IPFS, there is no car file on your side.
Right.
You just pull
What
the
is
DAG.
it?
And you pull it through GraphSync.
So it doesn't matter what GraphSync does because it's the car file that needs to be deterministic.
Correct. Yeah.
I mean, is there any? Huh.
But you're correct though. At the end of the day, we care about what lands in the car file, and almost certainly, I didn't say these are not written to car files as.
So wait, hold on though. What does the client use to calculate comp P then? So if the client pulls in the data off of IPFS and then it sends it to the miner over GraphSync, then they both need to get the same comp P. What is comp P being generated over on the client side if it doesn't spit out a car file locally?
Yes, for this, the client does. I mean, it doesn't spit out it used to spit out stuff, but yeah, now we stream it out and call it a comp P over literally the car export. It's the same car export actually that you have in IPFS as well. So if we have something with an inline CID, we can just see how it looks. I just don't have anything handy right now.
Cool. I mean, we should make sure the GraphSync doesn't send them either. God, that would be. I'm thinking about where these bugs would show up though, and they have an odd way of fixing themselves because if you ever ask for them from somewhere, you will always get them back. So I think even if there are incongruencies between these implementations, they're not actually going to show up anywhere.
And then what do all our Will, you're doing indexing for car files now, and I'm doing indexing in my own way as well. What do we do? Do you index the inline CIDs? That's the thing, and then you end up saying this CID does not exist within this data store, whereas we're saying for other data stores you want to return them.
But this CID
that's an interception layer.
Just return it.
Yeah,
just return it. I think that the data store should always just return the data for an inline CID. It may not be in the store, but it's in the key. So it's fine.
The whole point of the inline CID, it exists in every store. It is returned by every store. Every store stores it, and every store will put it and say, "Yeah, I got it," and every store will return it to you and say, "I have it," because
this is so going to get exploited someday. There's going to be some operation that we do where we ask somebody else, do you have this? And if they have it, then we know something about them, and somebody's going to find a way to get an inline CID into this. And it's going to
well, not really, because everybody will say I have it. You can ask anybody for any inline CID and they'll say I have it because they do.
It'll be like all these cache bugs in the browser.
Yeah.
There's freshness information that somehow, I agree. It's going to come up.
And this is why you block data URIs sometimes. yeah.
I think this is kind of the reason why I was wondering if we should push for inline CIDs or not. Yeah, but I guess also like this ship has sailed. I mean,
they exist. We have to deal with them. There's no way.
But I guess yeah. As I said, we could do a better job at explaining explaining what they're good for and not good, or like what they're good for and why you want to use them, or why you might want to use something else.
And what you should do, like documenting this conversation we just had about storage layers, should just return them if people ask for them, is a good thing to say, because I'm pretty sure that most of our stores don't right now. A lot of them don't. And then in Go, there's just this magic layer that goes on top of everything that makes all of it do this. I should say in Go Filecoin and Go IPFS. I don't think that that's in the Go IPLD stuff necessarily.
Yeah. So just also the background for the Rust stuff, we currently ship as default codecs. We only ship secure, cryptographically secure hashes. So therefore, no identity hash, obviously, because it's not cryptographically secure.
Wait. The identity ID is more secure than any hash you could use, because this
depends on what you're doing.
This is guaranteed to never have a collision. This is the data. You cannot collide it. There is no way. A hash.
That is a very interesting way of looking at it.
That is an entirely correct way of looking at it.
Okay. That's a good point. That's a good point. That's true. Yeah.
I would not say that it is the most secure method, because you do things with hashes other than just that. Like you may be relying on the randomness inside of the hash, for instance. Like we are now doing in chunky trees, for instance.
Yes,
we're
that's
doing
different.
A new hash, but
that's different from it not being secure.
That's true. Yeah,
that is secure. True. It may not let's separate
it's
collision.
cryptographically secure. Yeah, that's true. That's true. That's really true. Yeah, good point. Yeah.
It's so cryptographically secure you can always guess it.
One thing,
it's not encryption. It's a hash, right? And for validating data, it's great.
Yeah.
Did someone in the IPFS meetup in Munich, someone brought up that just mentioned in a sentence that you could do circles with inline CIDs, but I couldn't think of a case where it's actually true. So has anyone thought about that one?
No.
That you can basically build a, not DAG, but a cycle somehow. So it was just brought up briefly, so it wasn't discussed. So I wonder if it's actually the case.
No,
but I couldn't think of a case. I couldn't think of a case which actually works, but I'm still unsure. I put a bit of thought into it, and I couldn't think of a case, but I'm not sure if there's really I could in my mind there might be a way to kind of recursively the zip bombs
It's all the same problem as everything else. You have to get the CID with a hash in there, and that will be in the body in some mechanism of the parent, and so you can't do it.
Yeah, I think you can throw a pumping lemma at that and say, for no information is this possible.
Mm-hmm. If it were possible for inline CIDs, it would be possible for other CIDs too, for other data. I mean, it is the same thing. There's no way to put a link in there to a parent that is not a hash-based link. And so you would have to put that hash in it and pre-calculate it, and you'd have to know the parents, and it's in the body of the parent.
Yes, so if anyone wants to do a homework and spend the weekend on proof that it's not possible, I'm happy to read it. Anyway, is there any? So okay, so also coming back to the cozy stuff. So basically, we posted a little comment there with mostly questions. So basically, we say like the current state is like they should just go for what we currently have, because like it's totally fine. Like it's fine what they have now, and I've also talked with Eric briefly about it, that potentially we could still upgrade them to kind of unions. Like it's not a breaking change. So if we ever like decide that's a better way of doing it, we could. But I also think like we shouldn't like keep blocking them on anything. Like it's just like, yeah. So I will post a comment like concluding, like just writing, well, we've talked about it in the team, you can watch the recording, blah blah blah. Just do it, and yeah. Okay.
Yeah, I just dropped a bit of a comment on that big long PR already about this too, and the migration potential. I think another thing that we could use a lot of docs on in general in the future is migration potentials, because we've started thinking about this in this team and the people in this call on a regular basis quite a bit. But it's very non-obvious to people outside of this group, I think, what kind of migrations are easy and what aren't easy. And like, it turns out that, yeah, if we write something like this PR is written and it says, this is only links, and then we want to broaden that later to use a kind of union, I'm pretty sure that's one of like the easiest, most trivial migrations possible, because the new schema with the kind of union will always match all of the old data. It's great.
Yeah.
But we should really have a document that we can link people directly to that explains that.
Yeah. Also, people in their efforts to byte shave will move towards these really thin representations of their structs that make certain types of unions really, really difficult. So if you don't design for that kind of stuff and future-proof early, then you don't have any options down the line.
This byte shaving thing is going to come up again. Like, now that I'm dealing with the Filecoin data, I'm just having so much more sympathy for this inclination to byte shave. But at the same time, there's this sort of self-compounding thing where the byte shaving desire leads to smaller blocks, which leads to more complex graphs, which leads, like, it's one of these multivariate problem spaces that's really hard to solve for. And nobody's really doing a good job of mapping all the variables and their impact on the types of graphs that are built. And this is our job. This is something that we should be looking more at and being able to give answers. I was in a call last week, and I brought up this whole thing that we kept on coming back to, this cap theorem for IPLD that we've never fully defined. And I just couldn't pull it out of my head on, I was asked about it in more detail. And it's like, oh yeah, well, and it's just so many variables that it's complex to map them. So I know we need to do a better job at this, I think, somehow.
I think also, like, there's a lot of people that they have experience with immutable types. And so they're thinking about the cost of the representation, and they're not thinking about the mutation cost, because that's not like in their head, because that's not what they've worked with before. But like, you can't just think about the one-time representation of these and how many bytes you shave. You have to think about like how much of the structure is going to change and get orphaned as it changes over time, which is like something that you think about a lot in database engineering, but you don't necessarily think about in the immutable types world.
Well, and then the size of a CID as well is huge when you're doing large mutations of small blocks.
Yeah.
So just I don't know if we I know we're out of time. I'll just raise this thing I brought up last week to a few of you. But so in Filecoin, they have this mechanism that is driving decisions around data structure shape, where everything's gas costed. So every operation costs gas, right? And so how do you tune your data structures so they cost less gas? Like, and it's meant to drive the costliness of running the chain. Like it's meant to drive that. So the incentives are pushing down the costliness of running a node, because these things shouldn't be too expensive. So you don't have these perverse structures that are just taking up CPU and disk space. But to do that, it's like there's too many variables, as I've been saying, and so they've narrowed it down to some important variables. And a lot of it's based on benchmarking, but a lot of it is also just negotiation between people and other different incentives going on. So a lot of it gets detached from the real world, which it's difficult to represent the real world. It really is. And so for these data structures, they're primarily driven by three costs. There's the cost of a IPLD get, cost of an IPLD put, and a per byte cost. And the per byte cost is really small compared to the other two. And so they're having to heavily index on gets and puts. And so you can see what happens if a get and a put costs you a lot and you want to reduce the number of them, then you're going to drive up your block size. And if your cost on bytes per get and put is not high enough, then that just gets bigger and bigger. And so you end up with larger blocks, and then that costs you in mutation. So when you try and mutate, you end up copying these huge blocks and just changing a small bit of them. And so that drives up the amount of storage you need to store these blocks. But maybe that's the right decision, because maybe storage is cheap and dealing with the blocks is not. But anyway, that's what's going into these decision making. And it's just, it'd be nice to be able to engage in that conversation in a way where we can bring metrics and scientific some measurements and tools to it. Sorry, Peter.
Yeah, no, you're absolutely right. I basically want to harp exactly on that, not only the measurement tooling is not there, the measurement culture is not there either, because like there are a lot of misconceptions of what actually Lotus does and what level of caching exists and what is acceptable in terms of like how much we have on disk, how much we have in intermediate VFS cache, and how much we have in actual Go style, sized internal caches. This is being treated a little bit as a black box by the people who are doing the measuring, which is not the way to approach this. So I want to caution basically everybody on the call to not jump into design decisions before doing the measurement themselves. Kind of like our experience with Dumbo Drop, that until we verified every single thing works, and actually while the call was running, every single deal worked flawlessly for this person. So once we got everything debugged, the rest is kind of what's left is the right thing. So the same thing with the measurement and design. Like we need to remeasure everything at least twice to be comfortable with the numbers.
So this goes back to what our job is, though, because the reason it becomes a black box is because we're talking about, it's almost obscure knowledge. Like when you push it down to the block level, it's in a place where most programmers just want to throw it in a database and ignore it. Like I put it there and then I get it out of there, and it just goes there. And we've concerned ourselves with that space, and most programmers don't want to and don't. And so, and we see that in Filecoin, and we will see it again and again because most people don't care about this stuff. And we've concerned ourselves.
It's sort of our job to get them to that point too, right? Like an abstraction is useful if you can forget about it. But then like you want to assign the cost of something, and so you have to actually bubble up the cost of the abstractions in some way and understand them. And so all of a sudden you can't really live inside of any abstractions. You have to unwind everything and quantify everything. It's quite difficult.
Yeah. So our job is really to find that the way of boiling down the essences of these things to communicate them, I think. I don't think, I don't want to say that we're not doing a good job at it, but there's work to do here.
All right, we are running out of time. So is there anything else? No, then thanks everyone for attending, and see you all next week.